We're at Jake's house with Dave Wortell, the owner of Jake's house, and we're talking electrical grounding with building science deep dive. So let's get into it. So Dave, thanks for joining us today. And I'd love to actually look at what you've done here, because I'm standing over a giant copper wire and I've never seen one of these in a project, and we've done a lot of projects before. I would love to understand more about what you're trying to do here.
Sure. So this wire actually goes in a ring all the way around the basement, and it's what they call a ground ring. And it's going to provide safety for the people and the equipment that are in this house. As you probably know, all houses need to be grounded. My house is a little special because you can't use the concrete for grounding. Most houses have concrete that are embedded in the earth, and that concrete is conductive with the earth. And so the rebar in the concrete can be connected to and used as a ground. But in my house, it can't, because I've got all this insulation around it. It's sitting on styrofoam. It's got a water vapor barrier that's a polymer membrane. And for all these reasons, it's not able to conduct into the earth. So we cannot use the rebar in this structure as a ground. Now, the service entrance is at the far corner of the house, and that's where the most important ground is. The neutral that comes from the electrical service, where it connects to the panel, the service panel, has to be connected to a wire that's connected to a ground, to what's called a ground electrode.
And so what is, let me stop you there for a second. What does the ground do? Like to the normal homeowner that doesn't have an electrical engineering degree, what are they getting from that ground? Because you and I know that we have ground rods under all of our main electrical panels for our houses, but what does that do for the safety of that house?
So the wires that come from the electrical company, they're coming from the pole. There's three wires. In the normal American house, there are 220 volt phases separated by a neutral. And the neutral is how electrical energy gets back to the transformer.
So it's a round circuit.
It's a circuit.
Okay.
And there are actually two circuits. There's the red wire that goes through your house and through your light bulbs and outlets and back to the neutral. And then there's the black wire that goes through different outlets in your house and back to the neutral. Now, in the case that that one of these phases is using more energy than the other, then there's going to be electrical energy flowing on that neutral. Now, that neutral is grounded at the transformer, at the pole. If you don't also ground it where it reaches your house, then what can happen is, if for whatever reason that neutral gets damaged, either it wasn't connected right, or a critter bites through the insulation and causes some damage, or any number of reasons, that neutral could get severed or just have not a good connection. And if that's the case, then whenever you use electricity in your house, it can't make it back over that neutral. And if it doesn't find another way back to the pole, then what happens is your house is essentially in this floating condition, and it could have a high electrical charge on the house just from the energy accumulating in the house. And then someone who's standing on the ground and touches the house could get shocked.
So they become the ground rod.
They become the path by which the electricity, instead of going back on the neutral, goes up through the ground to the pole. So to prevent a person from becoming that conduit, what we do is, at the service entrance to the house, we connect the neutral to the earth, so that there's a path back to the pole through the earth. That's not through people.
That's interesting, because about 8 months ago, I had been having internet problems at my house for about 5 years. And we finally got somebody from the internet company to come out, and he's like, yeah, this connection with your internet is melting. and he didn't know why it was melting. And he finally figured out that a tree branch had fallen and broken the neutral in my house. And the electrical panel, because it's grounded, all the electrical fixtures in the house are grounded, it was trying to ground through the internet's cable, and that was so much flow for such a tiny wire that it kept melting the wire.
Yeah, that's exactly the kind of scenario that the ground at the service entrance is supposed to prevent. And so you should have your ground checked at your service entrance.
That's a good idea. So really what this is an additional safety measure for your house ground, but you're also going to have something here that most houses don't have.
That's right. So I'm a radio enthusiast, and I'm planning on erecting a small radio tower here. The radio tower itself needs to be grounded for a couple of reasons. One reason is that there's the risk of lightning strikes. If lightning strikes the tower, then it's going to create a current in the tower, and all the wires that are in the antenna on the tower down to where my radios are. And what I need to do is I need to shunt that energy, that electrical current, to the earth. So I need a ground that's local to the antenna that can do that.
Because if you don't, it potentially will fry all of your equipment inside.
Exactly.
Okay.
Right. Now, whenever you have multiple grounds at your house, you have to bond those together.
And by bond, it means connect those together so
Right.
that electricity could flow both ways on that.
Exactly.
Okay.
And so if I don't do that, then what can happen is that the grounds could have slightly different potential. Like, for example, the antenna could get a static charge or something on it, and the local area ground could be a different potential from the ground over there. And so my equipment, which is attached both to my electrical system and to the antenna, will see that difference and have problems. It could be that it gets fried, or it could just show up as noise. But either way, you avoid that by using a thick cable to connect the ground that's here with the ground that's way over there.
And the noise in radio operation, the noise ruins your ability to determine or to detect light
to tune in
frequencies.
signals.
Okay.
Yeah, the tuning in signals is always going to have some noise, but you want to minimize that, especially if you have different grounds, then the noise could be caused by the equipment in your own house.
Okay. Okay. So now, why does the loop configuration affect how well this performs?
Right. So, like I said, this is called a ground ring, and the ring has a couple of advantages. One is that I can connect to the ground ring at any point all around the house and have a very short connection to the ring from my equipment, and that essentially minimizes the electrical distance to the equipment, which is good for noise and for a lot of things.
Okay.
But one of the interesting features of the ground ring is that it can protect equipment inside the house from a lightning strike because of the lightning's, not because of the current of the lightning itself, but because of the magnetic field. Lightning strikes are such high amperage that they essentially create an electromagnetic pulse. There's an impulse of strong magnetic field in the area of the lightning strike, where even where the lightning didn't strike, that magnetic field is going to induce currents in circuits.
We could also destroy all of your electronic equipment inside the house.
That's right, especially radios, which are pretty sensitive.
Okay.
So a ground ring has the ability to actually suck the magnetic field's power and convert it into electricity going around the ring instead of electricity inside of the sensitive electronics.
Okay. So then, do all ham radio operators need a ring, or if they could have a ring, would they want a ring around their houses?
I think if they could have a ring, they would have one, but it's actually pretty rare. You see these mostly in commercial radio installations.
Okay. Now, I see that the wire down below is actually sitting on the rock. And is the rock going to be a good conductor of energy away from that wire, or do we do something else, or have you done something else down here to get it actually into highly conductive dirt?
So I am not counting on the gravel to provide any conductivity.
Okay.
It's possible that that some conductivity will occur as a result. In fact, the section that's laying on the gravel is really not that long. I'm actually counting on the I-beam supports that are going to be left into in the earth here to provide the conductivity to the earth.
So the soldier piles, which we had to do to hold up the earth so that we could excavate and build your foundation for your basement, are actually now providing a benefit which you didn't have before and which isn't really necessary for this, but is like an added bonus.
Exactly. When I was first planning how to do the grounding for this house, I figured I would make a ground ring, but my plan was just to drive ground rods in. When I discovered that we're going to have these huge I-beams embedded in the earth, I thought, oh, there's my ground rods already in there.
Okay.
And but I needed to connect to those.
Okay.
Now, when you connect to a ground rod, there are a couple of ways to do it. One thing you can't do is you can't just solder the metal to the ground rod, because the power of lightning strike would just melt that right off.
Really?
That's right. So you have to either mechanically bond the metal together, in which case there's a little bit of a risk that oxidation can happen in the joint. And
the oxidation breaks up that electrical conductivity between them. Okay.
Right. So the alternative is welding. If you can actually create a contiguous metal connection between the wire and the ground rods, then that's a very long-lasting, reliable, and low-resistance option. So that's what I decided to do.
And you've been doing that in the pit down here.
That's right.
Not a normal weld though, not like a welding torch and a stick, but actually a different kind of weld.
Yeah. So this application of welding is actually pretty common in the commercial electrical field, and there are products that make it simpler. So I don't really even know how to weld, but I can use this product.
Okay.
It's basically a mold, and this mold is made of graphite, which is a material that can hold its shape in spite of being heated to very high temperatures.
Okay.
And this mold, I push it up against the I-beam that I want to weld to, and I pass the cable through it, and then in the top of it, I put a charge. It looks like a K-cup if you're familiar with the coffee machine.
So a coffee machine, right? Okay.
Yeah. But instead of full of coffee, it's full of a material called thermite.
Okay.
Which are basically metal filings and an oxidizer that, when heated up enough, creates what's called an exothermic reaction. It gets really hot really fast. It melts all the metal, which drains down through the mold and then connects whatever the mold is touching. And that process takes maybe 15 seconds to finish. And then there's a really good connection of the wire to the I-beam.
If you're interested in seeing the actual welding, please look at our next video on this topic, which is the welding of the ground ring to the I-beams that are part of the shoring system in David's house. I appreciate David showing us that. And also I appreciate the understanding and the lesson in the importance of grounding your house and making sure that in the case of his house, if you are insulating your house from the environment through the use of foam, you may also be isolating it so that it is no longer a good electrical conduction into the ground. And we need to do something to make sure that that happens on every project with that type of design. If you're interested in learning more about building science or following our projects, please hit subscribe as we show you how to build a better way.